Ready to make a real impact every day? Join the Active Day Home Care team and help clients maintain their independence in the comfort of their own homes. Make a difference in someone's life as you provide essential daily assistance and protect their health and happiness. Earn up to $20 an hour and enjoy additional perks like optional daily pay, 401k, paid time off, ongoing educational training, and more. Join a team that values care, compassion, and your professional growth. Visit activeday.com to apply.
Hello, everyone, and welcome to Talk Nerdy. Today is Monday, June 16th, 2025, and I'm the host of the show, Dr. Cara Santa Maria. And as always, before we dive into this week's episode, which is episode number 555, I want to take a moment to thank those of you who make Talk Nerdy possible. Remember, this show is and will always be 100% free to download as long as we can keep making Talk Nerdy for you. The way that we keep it going is by relying mostly on support from individuals just like you. Once in a while, we can sell an ad. I think we sold like 2 this whole year. So yeah, really Patreon is the only funding source for the show right now. So if you're interested in pledging your support on a per episode basis, all you've got to do is visit patreon.com/talknerdy. That's patreon.com/talknerdy. This week's top patrons include Anu Bhadavaj, Daniel Lang, David J.E. Smith, Joseph Lamore, Mary Neva, Brian Holden, David Compton, Gabrielle F. Jaramillo, Joe Wilkinson, Pasquale Gelati, and Ulrika Hagman. Thank you all so much. All right, let's get into it. So this week I had the opportunity to chat with Dr. Carly Ann York. She is an associate professor at Lenoir Rhyne University. She got her PhD in ecological studies from Old Dominion University, but she considers herself an animal physiologist, as she says on the show. She previously wrote 2 nonfiction science books for children, A Day in the Life, Horses, and Queens of the Jungle. And she has a new book out. This time it is for you, the adult listener and reader. It's called The Salmon Cannon and the Levitating Frog and Other Serious Discoveries of Silly Science. So without any further ado, here she is, Carly Ann York. Well, Carly, thank you so much for joining me today.
Thank you so much for having me.
So I am excited to talk about your new book, The Salmon Cannon and the Levitating Frog, and other serious discoveries of silly science. I think this is a really timely and important topic. It may not feel like it ostensibly, but of course, we are struggling in the United States right now, and I think across the globe, with institutional support, or I should say governmental support. The institutional support is there of science, and sometimes the rhetoric that we often hear used is, oh, look at this. They, did an MRI of a dead fish. Why would they do that? What a waste of money. So I'm excited to jump into this with you. But before we get into your book, I do want to know a little more about you. So you're an associate professor and would you consider yourself an ecologist? What titles do you usually use?
I'm an animal physiologist. My PhD is technically in ecological science, but my work has been biomechanics and physiology.
Very cool. Do you have model organisms that you like to focus on?
I do. So in the past, I've done a lot of work on squid. That's
okay.
where most of my published research is. And I'm currently working on the African clawed frog and doing a bit of sensory physiology with them.
Oh, that's really interesting. I remember a million years ago when I was working, the first time I attempted my PhD, I taught animal physiology in, this was actually when I was getting my master's. Yeah, I taught animal physiology lab at the university where I completed my master's degree in biology. And we covered so many things, like almost every kind of system within the body. So animal physiology is a pretty broad brush, right? It's the other half of anatomy. It's the how things work. What specifically, you mentioned some sensory stuff, but what specific parts of kind of physiological processes are you interested in?
Most of my work has been in the realm of sensory information. So I was looking at how squid detect and avoid a predator. So I was looking at their use of vision versus their use of these little hair cells that are along their body called the lateral line analog, how they would escape in dark conditions versus light. So I was trying to kind of parse out just what system they use when.
Okay. And so was that for your dissertation?
Yes, it was.
Oh, interesting. And now, as an associate professor, are you teaching only, or are you teaching and also running a lab?
I am at a small liberal arts school. So I am mostly teaching. I have a really, really heavy teaching load.
Oh, that's so fun and so rare.
It's very heavy. I wish I
Yeah.
had a little bit more time for research. I have my frog colony, and when I have an excellent student that I can put into a research program, I do so. So I get to mostly do my research through the students.
Yeah. But how wonderful. I mean, it does sound like kind of exhausting as well. But very often when I talk to professors, they're like, I wish I could teach more. I have the one class I teach every year and it's kind of the same thing. And I love teaching, but I don't get the opportunity very much. So I guess the grass is often greener.
Yeah. It's a sliding scale. If I could be a little somewhere in the middle of those, that would be awesome.
Yeah.
But I do love teaching. I really do.
Oh, I love it. And of course, I think there's a big translation between teaching in the classroom, whether you're teaching undergrad students, graduate students, high school students, even elementary school students, or the public at large. And that's a big part of what it is to write a trade publication. Like a lot of academics are involved in, textbooks or writing peer-reviewed journal articles. But of course, when you write a book for like a consumer who maybe has never taken a science class or they don't remember the science classes that they took, it's a very, very different animal. So I'm curious what kind of inspired you. I see that you have written books before, but they're a bit different.
Yeah, so I have two children's books that I wrote before, which were hard to write in a different kind of way. I was doing science communication before I really knew I was doing science communication. I have two TED Ed videos that I worked on. Gosh, it was probably like 7 years ago now. These little 5-minute animated videos for anybody to learn a little something. And I did it on squid and frogs. So that was probably my first little step into trying to translate scientific information to the general public. I also teach the non-majors biology class at my university, and I have taught that every semester, I think, for the past 8 years. And it's actually my very favorite class to teach. I know a lot of people are like, ooh, the non-majors. For me, it's just an opportunity to SciComm. And I love having the opportunity to take this group of students who they walked into that class because they had to, because it's part of our curriculum for them to take a science class. And they're not particularly excited to be there. And many of them have had unhappy experiences in high school. And usually by the end of that class, I've gotten the vast majority at least willing to engage and feeling comfortable enough that they can engage in science.
Yeah. Yeah, it seems like a lot of the discomfort, and I mean, I can attest to this as a girl growing up in the patriarchy, right? That when I was young, science just scared me. I just didn't think I was good at it. When I felt that it was difficult, instead of having the reinforcement that, like, yeah, it's difficult for everybody. Like, this is really complex stuff. But you can do it, and some things are going to be harder than others, and everybody has different experiences. Instead of getting that kind of feedback, I got what most people get, which is, well, it's not hard for him.
Mm-hmm.
So I'm just going to keep calling on him, and he's going to shine in the classroom. And because it feels hard for me, maybe that means I suck at it. So maybe I shouldn't try as hard. And, then that horrible stereotype threat, like never ending cycle. And I think we see that a lot with folks who, and not just girls, obviously, but we see it across the board with folks who had either a bad experience or just like most people, like this was challenging. And because it was challenging, maybe that means I suck at it, which, gosh, I just wish we would admit more often that it's challenging even for the experts.
Absolutely, because it is. It's hard, and when you're trying new research, you are absolutely going to fail. And I wish that was just like a line that they put into the scientific process when they taught it. Like, you make your observation, you make your hypothesis, you run an experiment, and then you fail, and then you do it again, because that's it's inevitable, but it's not necessarily taught that way. So when people run into their first wall, they'll often stop right there.
Yeah. Yeah, it's so true. So I love the fact that you took a lot of these sort of stories and experiences and anecdotes, and you got to kind of broaden that audience outside of the classroom to anybody who is able to pick up the book. I also saw that you have a blurb from Mary Roach on the back of the book, at least the kind of preprint copy. And Mary is she's a friend of the show. She has a new book out, so we're going to have her on in a few weeks, and we've had her on previously. I have to admit, she's one of my favorite authors. The way that she writes with sort of wit and charm, but always a certain amount of reverence, I think is something to aspire to. I'm curious, do you feel like she inspired you? Had you read her books before you wrote this?
Yeah, absolutely. She really inspired the tone that I ended up taking this book. She kind of gave me permission to be, I don't want to say a little unserious in a way. I mean,
Yeah.
just that it's okay to have some fun with these topics too. Like they can be serious and they can be fun at the
Yeah,
same
they can be
time.
fun, they can be funny, they can be a little dark, and there's always that balance, which I think you struck really well, of taking the piss, but also recognizing that even when something feels silly, right? And you even use that word in your subtitle, silly, that it matters and there is an outcome and there is kind of a let's say, I mean, reverence, yes, there is a reverence there, but also there's a meaning and an improvement, whether it be for the environment, for health and human safety. There's a bigger picture sometimes that people don't always see when they hear, or they read the headline of an article about efficient an MRI machine. So let's dive into that. How do you define sort of silly science, and how did you pick some of the stories that you told?
I define silly science broadly falls under the category of curiosity driven science or
Mm.
basic research. Any kind of research that doesn't have an immediate application goal, where the scientist simply has a question that they are looking to examine
Hmm.
and they have no idea how that could potentially be useful. And historically, this kind of science has been incredibly valuable, because we don't know what we don't know, and then we don't have that information to answer future questions. So I started with that, and then I was taking a look at the kind of research that most commonly got dragged by politicians, because there is plenty of that. And from there, I wanted to dive into the stories of the people who had actually experienced it.
Yeah, yeah, that makes sense. That makes sense. So, how did you choose? Did you go in order of the most buzz, or did you start kind of slower? How did you choose how to organize your book?
Oh, it came kind of in a few different phases, honestly. When I was starting, I had it organized a complete different way. And I sent my first 5 chapters to my editor, and I was really proud of them. And she wrote back and was like, let's have a conversation. I'm like, okay. She's like, what if we completely redid it and looked at it a different way? So I cried a little bit over that, and had to take a minute.
Yeah.
But I think the book is better off for it. So what I was trying to do with the chapters was, explain the value of this kind of research, but also break down the scientific process, because I feel like that's a big thing that's missing from the public's understanding of what we do. I wanted to show that this is not a linear process, that we just simply can't predict what we could possibly find, and there needs to be room for that in our process.
Yeah. Yeah. So give us an example. Like, what is probably, I mean, you've probably been doing podcasts or radio interviews, like the book, all the fun book tour stuff leading up to the book being released. The book is chock full of all these interesting stories, but they're, whether it was you, whether it was the publisher, whether it was the editor, the salmon cannon and the levitating frog are right there in the title. So talk to me about the salmon cannon and the levitating frog.
Sure, I will say that was the publisher.
Yeah.
I had a little bit more of a raunchy title that I suggested, and they said absolutely not, and
That's
suggested
hilarious.
this instead, and so it
Okay,
is. Right. Um, they let me put anything I want on the inside, but the cover they were pretty controlling over, and that's okay.
Okay. Yeah.
So the levitating frog is a story about this physicist. His name's Andre Geim, and he is super duper well renowned in the field. But he would every Friday have what he called Friday night experiments in his lab, where like all bets were off. You could simply follow your curiosity and do whatever weird thing you wanted to, zero judgment. Like he actually thought it was really good to step outside your field even and look at a question from the eyes of an amateur. So he was working in a lab that had this big electromagnet in it, and he first decided to pour water into it, which he literally said later was a pretty unprofessional move. And what happened was the water started levitating. And he didn't expect that to happen. So once they saw that, everyone in the lab was like, oh my gosh, what else can we get to levitate, right? And they ended up borrowing, I put that in quotes, a frog from the biology lab down the hall and put it into this electromagnets, and it levitated. So this was the first time that there had been magnets strong enough to levitate something as big as a frog. So it sort of opened the doors to other ways that this phenomenon could potentially help us down the road. It does require very, very big magnets, though. He had people who wanted to be levitated, and he had to tell them he could not do that with these magnets.
Did it hurt the frog or anything?
It didn't.
That's cool.
They said this. They said he was totally fine. And there is, I don't have a picture in the book, but there is a picture online of this frog floating in the electromagnet, and he does look totally chill. He's just hanging out.
Nice.
Yeah.
That's good. Yeah.
And then the salmon cannon, that is a piece of equipment that was designed to help salmon during their migrations. So salmon, they breed in freshwater, and then they'll go out to saltwater, and that means a considerable amount of travel. Because we have put so many dams up in our rivers, we've created these impediments for their migration. And there have been multiple attempts to try and help them to overcome the dams. There were some fish ladders, but they just didn't work particularly well. And the salmon cannon is a pneumatic tube that people will physically put the fish in, and the tube will suck it up over the dam and spit it out into the water on the other side.
Oh, okay. And so
It's been really helpful with migration patterns for salmon and keeping their population levels high.
And the fish are okay with this?
The fish are okay. Well, I can only say so much, but the fish welfare is a concern. So the pneumatic tube uses air to push it through, but they also have misters all the way through to make sure they're still staying nice and wet. And it's a pretty quick trip. Like, they're moving fast through that tube, and they come out the other end and they seem fine. So that's all I can't ask them. That's what I know.
So talk to me then about like whether we're talking about the salmon cannon or the levitating frog, there was a problem or there was a curiosity. That problem was solved or that curiosity was kind of the itch was scratched. What came from this, right? Because obviously in the shoes of like, let's say a politician who is anti-science and who wants to defund science, it's just like, I can't think like that,
Right,
because I am a scientist. But if I try to put myself and kind of empathize with that position, these things sound silly, they sound lofty, they sound pointless. But what is the point?
The point is to simply know as much as we possibly can because we can't predict the future. So I have stories in here that already have applications. I have stories in here where they're working on potential applications. And I have stories that do not yet have any intended application. And my point in doing that is to say that we simply don't know, but this is all valuable and all worth funding because of what it could be.
Can we have maybe some examples of that? Like, or maybe I could ask. Let's stick with the frog and the salmon cannon. Obviously, the salmon cannon has an application. It's solving like a problem, right? We needed to get these salmon across. Now they get across, and they do it somewhat safely, and they're healthy, and they're able to breed. But what about the frog? Do we have any like big takeaways from that? Have we learned something or broken through? Are we able to do something we couldn't do before?
In terms of applications, it's really just a better understanding of physics. And I think it could potentially help industrial wise. I don't have a specific example of how it has, but it's certainly advanced our understanding. I do have some other examples within the book that do have more immediate, direct applications. One, for example, is studying the venom of Gila monsters. So these are venomous lizards, and they have kind of a funky ecology where they can go for months and months without eating. And there was a researcher who was looking into their venom and found that they had some interesting peptides going on. And then later, with information from more researchers, almost everything in here is collaborative. There was interest from someone who had been working on diabetes and trying to find a cure for diabetes. And what they found was that the Gila monster is able to go for as long as it does without eating is because it has a specific peptide that helps to regulate insulin production. And it is very, very close to a peptide that we have called GLP-1.
Yeah.
The problem with just using GLP-1, though, is that it has a super short half-life. So it just doesn't sustain insulin at steady levels. But the peptide that was found in the Gila monster venom actually was able to stabilize insulin levels for several hours. So that became what we now know as Ozempic and the other names that go with that. And of course, it started as a drug for diabetes, and now it's being used for obesity as well. So that certainly has become a popular outcome of just a curiosity-based project trying to look into what kind of proteins were in that venom.
Oh, that's fascinating. I love that. Like, I mean, and I think a lot of people can attest to the fact that that's like been completely life changing for them. And we wouldn't even have known about it if it weren't for these sort of these non translational researchers. That's really fascinating. I was going to mention with the when we were talking about the levitating frog, so often I feel like that is also the response that I hear when it comes to like particle physics research. Like, why build a Large Hadron Collider? Why smash these particles together just to have like these fractions of a second and discover these like, subatomic particle? What use is it? And it's like, well, what use is it to try and understand the early universe or why we're here? You know what I mean? Like, and yes, like technology can come from this, and it can lead to important translational things. But even if it never does, understanding like the basic philosophical questions, who are we? Why are we here? How did we get here? Where are we going? I mean, isn't there something fundamentally important about that as well?
I sure think so. And I wish that logic was a little bit more prevalent, especially within politicians. It's so tough because everyone wants a measurable outcome, and it's not always easy to provide that. If you look over decades of time, you can certainly see the patterns. I mean, Einstein's research wasn't useful immediately, and then it became how we were able to establish GPS. Most of the physics geniuses that we know of, like Faraday, their work wasn't immediately relevant. But then when we talk about things like quantum mechanics, we wouldn't have those without him.
Yeah, yeah. I don't know. I guess I'm wondering if you, in working on this book, obviously you are a researcher, you are somebody who is trained in the sciences, who has published as a scientist. But in working on this book, you did mention that there's like this pressure, right? When you're a scientist and when you're publishing in peer-reviewed journals, there's a pressure to talk about the why of it all. And sometimes you won't get funding. Like if you're applying for grants, like unless you can really demonstrate some sort of utility, you'll be passed over for funding. Do you, this is kind of a tough question, so it's totally okay if you're like, nope.
Okay.
In working on this book and in doing this research, have you developed any insights, like kind of worth sharing about how scientists can better sort of communicate to these naysayers why they're doing their science? Is it about sort of coming up with like, maybe it'll do this, or is it about defending, hey, it doesn't matter that it might not do that. It's important anyway.
Yeah,
Or somewhere in between.
Yeah, it probably depends so much on who's reading the grant itself.
True.
I've always gotten the impression they really want you to make up a potential pathway. That's what I was always told. Like when I was doing my squid research, there was always the possibility of robotics, or that was never my goal. But
yeah, that's true. I mean, it is sometimes hard to think about, but science is pretty siloed still. It's getting better every day, right? It's more and more multidisciplinary than it ever was in the past, but it's still somewhat siloed. And so very often when, let's say a chemist is doing research on their, chemistry, or like a material science is just playing with this one like aspect of like a polymer, they're not thinking about the sort of potential outcomes that different experts in different fields may be able to take and run with their science towards.
Yeah, absolutely. And that's how most of the stories in this book end up going, that we have people from all different corners of science that ultimately played a role in what became the big discovery or the big application. Collaborative work historically has been rewarded in funding. And I think that is a super, super important part of it. I will say that writing this book helped me feel better about doing my work that doesn't have an immediate application. Going through and studying the history and even like looking at data, I found a paper that said that 80% of drugs that are on the market now came from a basic research project that had no intention of creating a drug. I think stats like that are pretty powerful.
Absolutely. Yeah, I can imagine that must be really validating for, the percentage of like graduate students and early career researchers who are, driven by curiosity, but have bumped up against naysayers, professors or administrators who have kind of like poo-pooed their work and said, come on, this isn't important. Like, why aren't you working on Alzheimer's or Parkinson's or cancer or, kind of the big funded.
Yeah, exactly. Or even just family members who would really like you to be working on something they can understand, like that medical research versus, why squid swim so fast.
Yeah. It reminds me of sort of the old adage that a good scientist is kind of equal parts skeptical and open-minded. And I think a lot of times we don't talk about the fact that science is fundamentally at its heart a creative endeavor. We think of it as like a stuffy academic approach. We think of it as almost like the opposite of art. But very often, arts and sciences are in the same, college at a university, and there is you cannot do science. You cannot be a scientist and do science if you can't think creatively. It's like it's
Absolutely.
necessary.
Absolutely. Yeah, I have a chapter in here that is, it's called the eccentric experiments. And that one is centered around really creative solutions to problems. So one of them is very directly related to the arts, and it's about jumping spiders and sexual selection. And the lab was trying to find out what the red faces of the males meant to the females. So they ended up actually taking a picture of the spider to Sephora and getting them matched with an eyeliner. It was Urban Decay that they ended up going with. So they had this. They're like, it's non-toxic, and they could paint the spiders different colors using eyeliner. They have another experiment where they've actually used some false eyelashes to create tufts. So they've done some really interesting stuff in there.
That's hilarious and adorable. And it must be so fun to, I don't know, to publish something like that, like to include
Right.
your photos and to write it up. I see so often that sometimes scientists will work on projects that do feel a little bit, I don't want to say esoteric, but like a little bit heady and a little kind of confusing, or, they just require understanding a lot of jargon. And one of the most fun parts is like coming up with the title of the paper.
Mhm.
Yeah, figuring out like the acronym. And you see this playfulness all the time in science. Like you see, genes or factors or proteins called things like Sonic the Hedgehog. And like,
Mhm.
it's like, yeah, there's a whimsy and a humor within the scientific community for sure.
Yeah, and the general public doesn't get to see that nearly enough. Like, there's such a narrow view of scientists still in our culture. I know it's getting better in terms of like, yes, women are scientists too, but still, I think we're expected to be really kind of cold and calculating. I don't think the media has done us any favors. Like, I personally, the Big Bang Theory really irks me because I feel like it feeds right into every stereotype that we're just weird. We're just weird people who you can't
Yeah,
relate
no,
to.
yeah. I would agree with that as well. I think that, and I think it's a larger, I mean, this is just me pontificating, this is my soapbox, but it's a larger cultural problem of living in a patriarchal society that the patriarchy itself has sort of constrained the experience of women so much that there is this almost innate feeling that there's plenty of space for men, but if like there's only so many slots for women. So if I get it, somebody else doesn't, or if they get it, I have to compete with them. And so now all of a sudden we're not cooperative, but we're competitive. And the way to fit in if you're competitive is be more man-like. Well, if I act more like a man, I'll be more accepted in these lab meetings. And then it's true. Like that's the problem is that that's the feedback that people get. The more I kind of follow the male rules, the more I sort of climb the ladder.
And I've experienced a little bit of that in the past few years, actually, with my writing. I was saying to someone earlier that I want to start keeping a list of adjectives that people use for my writing. Um, I just had the review come out for this book in Science, and it was overall a perfectly fine review. But the reviewer said that I was a little too bubbly
Ugh,
for.
yeah, they would never use that word for a man.
Right,
Never.
right,
Yeah,
right.
yeah.
I submitted a pitch to an editor at Scientific American a few years ago, and they wrote back and said, "This is a little too cute for us." Again, things that I don't think that language would be used if a man had submitted it.
Absolutely not. You are completely correct. That's so frustrating. And I don't know if you've ever seen the sort of like trending videos online where ChatGPT or Google is at, like, the search engines are asked, like, describe a woman, or describe what adjectives, describe a woman or a girl or a man or a boy. And they're just like wildly different, and not just wildly different, gendered in a fundamental way, but just like deeply insulting, right? Like,
Yeah.
boys are strong and girls are sweet. And yeah, it's like, it's also superficial. Yeah, that must have been infuriating for you.
Yeah, and I mean, I do wonder if part of it is that this writing style is so uncommonly used in the sciences. And of course, this book wasn't written for people who read science. Those are serious scientists. This is meant for the general public. And if I have to err on the side of being, too inviting, like that's what I want to say I am. That bubbly equates to being inviting to the general public. And I certainly do write like a girl, I'm sure. And and that's maybe not a way that people are still really used to reading science.
Yeah, it's like, yeah, it is important, and I think you see it across the board. You see it in so many different fields that have been dominated by men for so long that, I'm remembering, and I referenced this on another episode that I recorded previously, but that hasn't aired yet. So I'm time traveling a little bit. But I was talking about the film that Kate Winslet starred in, that was based on the war photojournalist, Lee, right? And Lee Miller, in World War II, and how when editors were looking at her photographs, they were like, only a woman could have taken these photographs. Like, because, right, like, we see the world through the male gaze. We have to. We were trained in it. It's the default perspective, and we've learned to speak men, and we've learned to see through the male gaze. But we also have our own gaze, and men never learned. They didn't have to, right? How to see the world through the female gaze. And so I think every field, whether we're talking about writing about science or taking photographs of war, all of a sudden it's a very jarring perspective shift for the general public to see something through the eyes of a woman, or to feel a woman's perspective in the writing. But you can't help but have it come through.
Yeah, this isn't something I have thought about until this very moment. So thank you.
Well, I'm glad that you sort of unapologetically maintain that perspective. I think it's so important to do so, because I do think that again, like we mentioned, there's an implicit pull to sort of, I don't know, mail up our perspective, like you get enough rejections from people saying it's too bubbly and it's too girly and it's too whatever. The initial reaction is not to double down and say, well, I'm going to own my bubbliness and girliness, and this is equally valid. The initial reaction is to go, oh, I guess that there's no space for me, or I guess that I'm not palatable to people, and to make ourselves smaller. I mean, that's what we've been doing our whole lives, and that's a huge bummer.
Yep, it is a huge, huge bummer. And it's been, right now I'm the only female. Oh, one other just joined our faculty in biology, but still very, male dominated group here. When I joined the faculty here, I just like got in a mood about like really doubling down about being girly, because I felt like I was never allowed to do that in graduate school. But once I graduated, I had my PhD. They couldn't take it away if I decided to wear high heels.
Right.
Right, and
yeah.
now I'm old and tired, and I don't want to wear my high heels anymore. So I don't. But I had that moment of really leaning into it.
I love that so much. And I love there's no one way to be a scientist. There's no one way to be a woman. You've got everything from, high heels and a lab coat to, whatever the opposite of that would be.
Yeah.
but the perspective, I think, does come through, and I think it does matter. And I think that there is a real link here between having the recognition that, fundamental curiosity, fundamental questions in science that just matter because they scratch an itch, that matter because that is what scientists, have always endeavored to do, is to just understand. Like, I have a kind of, I guess, maybe a faith. I don't know if I like that word here as an atheist, but like I have a a true kind of belief that something will come of it, even if it doesn't come in our lifetime. Right? So long as the science doesn't get buried, so long as it doesn't get, pilloried and covered up and people go, "Oh, it's so stupid. I'm gonna pull all the funding and I don't even wanna publish this," so that nobody has access to it. So long as the data are out there, somebody will ask another question in the future, and they're doing their lit review and they stumble across the paper and they go, "Oh, they already did it this way. Now I can try it that way." Or, "Oh my God, I can't believe they figured this weird thing out. Look at how that applies to my work." Like, it's
Mhm.
gonna happen.
Exactly, exactly. And that is also why we are in such a kind of scary political place right now with data being removed from websites and all that jazz. So that's a
Or
different
data
story.
being invented, right? Like, fake
Yeah.
citations being included. And really, like, when it comes down to it, I mean, we could talk for hours. It's only because of the timing of the show, and we won't do it here. But I'm here in Los Angeles. You may have even heard, like, picked up on the mic. I'm hearing voices, kind of outside my home, and I don't know if there are marches down the street. I'm not sure why I'm hearing those voices, but there's a good chance it could be that. We are at a really important inflection point when it comes to authoritarianism, fascism, overreach of power. And one of the fundamental things in the authoritarian playbook is this Lysenkoism approach to science, right? It's, I want to fund only the science that pushes my authoritarian agenda, and anything that threatens the sort of, any free speech approaches that threaten the, let's call it anti-vax if we're talking about RFK Jr., or let's call it anti-DEI if we're talking about sort of white supremacy within the administration. Any science that threatens these antiquated or, let's say, unreal, like these not reality based political agendas are quieted, right? They're squashed, and then sort of the pseudoscience fills in those gaps. It's a super scary thing that dictators can do, and we're in a place right now in our country where we don't know which way it's going to go.
Yeah, yeah. And sadly, it seems to be headed in the wrong direction.
Right. And so,
With
what is the role of scientists and, let's say, non scientist citizens who value and want to support our scientific communities and our scientific endeavors? Like, what do we do about this?
no, I've been asked this several times, and I have like a crisis after each interview where I'm like, oh my God, I don't know, what are we gonna do? And I feel like there's multiple levels of like what can be done, and people are doing things. There's a group of grad students that they've developed this project called the McClintock Letters, where the goal is to write into your hometown newspaper explaining what you do as a scientist and what your work is and why it matters. I like that from a SciCommer perspective because it touches those more personal connections. Like, oh, maybe this person grew up down the street from you. Um, so I really like that. There's, of course, the big protests going on. I think that's a great way to make sure that our numbers are seen. It's limited in actual action, but it's something. I think that you can also obviously write into your local congressman and all that jazz, and there's some good resources for that online. Ultimately, I think we're going to have to see the way that we fund science dramatically change after this. Like, the vast majority of research in this country has been funded by the NSF, the NIH, the DoD, federal funding. And that has been wonderful. That's the way it should be. But if it's going to be at the whims of a politician and it's going to change with the shift of each administration, I think we, as a discipline, need to start looking seriously at how we can be more sustainable and more resilient to shifting political opinions.
Yeah, there has to be some sort of safeguards in place, whether it be, specific committees that are more robust or rules, or, I think one way to also counter that is to elect scientists to public office. Like, I think that there's been a sort of vibe. I don't know, that's such a weird word to use in this context, but a sort of culture within the sciences for so long of like, oh, but we're apolitical. Oh, we don't actually talk about that. We don't actually go there. We don't actually, advocate or we're not activists. I'm sorry, we can't afford that anymore. Like, we can't stay out of politics or we will die. As a scientific community, we have to engage politically. We just have to. Science is political now. I wish it weren't, but it is. Yeah. And so I'd love to see, and I hope I do see, because very often I think when there are huge pendulum shifts in political discourse and ideology, and as that sort of window is shifting to the farther and farther to the right, I think that we do often see reactions. I think Trump was definitely a reaction to Obama, and I want to see an equal and opposite reaction to Trump. And maybe that reaction is going to be more women, more people of color, more scientists, more scientific skeptics, kind of running for public office, becoming present, not being afraid of having their voices heard, learning the political ropes and playing the game. I mean, I hope so. I'll vote for a scientist for sure.
Yeah, no doubt. I hope so too.
Yeah, it's funny because I don't know about you, but my political persuasion, I mean, anybody who listens to the show knows that I'm like left of left and that I'm very liberal, but I vote as a Democrat and I am registered as a Democrat because I want to vote in the primaries, but I don't consider myself a Democrat. I consider myself an independent, and very often, like, I side with the science. There was a time, like, I'm very pro GMO, right? And like being pro GMO sometimes puts me weirdly like positioned on the right on certain issues, which is like, what is happening? But it's because I follow the science. I don't follow the political ideology.
Right. I completely get that.
And it's interesting that that has not never, but that has often not been a, I don't know what you want to call it, but like a parameter. Like political ideology has very often been about economics and it's been about third rail social issues, but it's very, very rarely been about reality testing, about evidence bases, about skepticism. And I wish that we saw that more in the political discourse.
Yeah, absolutely.
I'm curious, when you started to write this book, did you have any idea what the political landscape was going to look like, or whether you would be having these conversations, as the book was published?
Obviously, I wrote the book because questions of funding in science aren't new. They've been around for quite some time. I certainly didn't know it was going to be released at a moment when we're having such an extreme situation presented to us. I wish it wasn't. I wish we were not having such an extreme moment here. But I'm glad too that it's coming out, and I hope to have the platform to be able to maybe give information and change some minds that otherwise wouldn't.
Absolutely. Yeah. I'm curious, I guess, as we start to wind down the interview, what kind of an impact are you hoping that the book has? I think that there's, some people, they sit down and they write a book with an intense purpose, and everything they write is sort of in service to this big takeaway. Some people write, which I'm assuming is more the way that you wrote, but correct me if I'm wrong, with just a fundamental curiosity and a passion and a love for these stories and sharing these stories. And then sort of, okay, but also I hope that this is a big takeaway. Regardless of that approach, I'm curious, A, which was your approach? And B, what are those takeaways that you're hoping that people that people take away. Wow, that's redundant.
Yeah. No, it was honestly kind of a combination of that. Like I sat down to my goal was to prove the value of science that has been called silly science, and then the stories followed from there. So my goal with this is, first of all, I really want people to understand the scientific process better. I've tried to weave that throughout the entire book, that it is not linear, that things come as surprises to us. And I also want people to understand that when you see these scientists getting dragged for whatever reason they've decided that day, I want them to be able to critically think about what is happening here, and at least admit that maybe they don't understand the research, that if it sounds this ridiculous, there's a likelihood that maybe they just don't have the depth of knowledge to know where it's going. And that's an opportunity for learning. I have an example in there where Sarah Palin bashes on fruit fly research. And of course, no scientist would ever question fruit fly research, but
Right. Yeah.
to the layman, it's like, oh, it's a stupid fruit fly, right? There's actually
it's only like the model organism, right?
Right. There's so much that we learn from that stupid fruit fly.
Ask Andel. Yeah, ask any researcher who is like,
yeah. So those are my two major goals I hope people take away from this.
I love that. And of course, we could have spent the entire hour sharing really fun stories from the book. I always try not to give away too much of the actual content. It does sometimes feel like on my show, like we circumlocute and we don't hit the sort of main points that a lot of like press releases want you to hit, because I'm like, read the book. I don't want to give away the whole damn book. The whole point is to, get the book and read it. But here in these last like kind of minute or two, I'm curious if there are any stories that we didn't share that you're like especially fond of, or that you think are especially interesting that you'd like to share with the listeners.
I did spend some extra time featuring the research of three of the folks, and that's because I also talk about their experiences in the political realm as well. So one of those is research that was done by David Hu, who is a physicist down at Georgia Tech, and his research is the quote-unquote law of urination.
Okay.
Which is the law is that it will take 21 plus or minus 13 seconds for any animal that's larger than a rat to pee. And so he had students out measuring the urination rates of like every possible animal that they could find. And this obviously does sound really silly, but it's been useful both in human health and in the design of prosthetics. Ultimately, what he found out was there's this specific ratio between the diameter of the ureter and the bladder. And so even if you're an elephant, you're going to pee for about the same time as a dog because of this ratio.
Oh my gosh, that's fascinating.
Right? Yeah. So it's being used with the potential design for prosthetics. It's even just being used in the design of like water towers and hoses. Like, how can you get water to move without exerting this extra pressure?
Wow. Oh, that's so interesting. Oh, I never knew.
It's a fun one.
Yeah. And talk about physiology. I mean, it's like a great like basic physiology understanding that like, yeah, is probably, again, has all these like potential outcomes for like urology and nephrology and, different biomedical approaches, as well as just basic animal research.
Mm-hmm. Yeah.
Oh,
absolutely.
That's fascinating. I love it. Well, gosh. So, I've been chatting you up now for nearly an hour. There's a million other things that we could talk about, but of course, that is the point, everyone, in picking up the book. It's called The Salmon Cannon and the Levitating Frog and Other Serious Discoveries of Silly Science by Dr. Carly Ann York. Carly, thank you so much for spending time with us today.
Thanks for having me. This was wonderful.
Absolutely. And everybody listening, thank you for coming back week after week. I'm really looking forward to the next time we all get together to talk nerdy.